So since the last video, we've had a few more libraries pop up. This one, base, seems like good and well documented, and there's also a manage wrapper for it because it's unmanaged. So it looks like it supports obviously all the platforms based on this, which I'm pretty sure it will. And let's have a go at implementing this, but instead of it just being the usual way, let's have a go at using ChatGPT. Now, I've never used this before. I've just created a brand new account. I've also never used this managed base before. So the idea is, let's see if we can use ChatGPT to write us some sample code for capturing audio any quicker than using the actual samples library, or in this case the managed repository has samples repository as well. So let's just take a look to see which one's better, or if ChatGPT has got anything useful in terms of helping us with development. There's a lot of hype around this. I've never used it. I don't think the hype's going to be what it's lived up to be, but we'll see. So first off, we know in our project we're going to need a new service. So we'll call this one audio capture service, and we can do an interface after once we know what we're doing. For now, we'll just directly make a single interface, and we'll just do public void, keep it simple, capture default microphone, or capture default input, and we'll start in there. So we will need to manage NuGet packages, and we'll need managed base, which looks like this one. Yep, unforeseen audio library. We'll add that to the project. And then I believe when I glanced over this home page somewhere, it mentions something about needing libraries. Here we go. So it targets any CPU, but base libraries, DLL, SO, blah, 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 are separated. Download the versions needed. So that will be quite clearly these download links here. So let's just click on Windows and Mac and Linux for now. And once they're downloaded and you extract them, these are just in the subfolders of each download. So you just want the DLL for Windows, the dynamic lib for Mac, and the SO for Linux. Let's just go ahead and copy them libraries. And because they're going to be desktop specific, these are desktop versions, not mobile, we'll paste them in the Avalonia UI desktop project. And this is all pretty standard stuff when you're adding libraries to projects, unmanaged libraries. So if we now go to Rider, you can see them here. Select all three, properties. We don't want to build anything from them, but we do want to copy them if newer, so they'll appear in the root directory. And I presume that's all we'll need for this to work. So we've set up the NuGet package and the libraries, and the next step would typically be to go to samples repository. So you've done that, and then it's samples. So instead of doing samples this time, let's jump over to ChatGPT and I guess tell it to write us some code. So let's just start with write me some sample C# code for managed base to read the microphone audio, and I think that should be enough. Yeah, no way. So it does appear to be writing some C# code. It's realised it's unforeseen base as well, the actual project. That's quite cool actually. It does appear to be writing some code. So the interesting thing will be, does this work? I'm quite surprised by that. I didn't expect it to do that. It's got callbacks and everything. And it even explains what the code does. Initializes managed base, creates a recording stream with a default recording, which is what we want, sets the recording callback, and then waits for the user to press the stop. The recording callback receives audio data to the buffer, converts to a byte array, which you can then process. That's literally perfect if this works. So let's just take the code in main and copy that. Paste it straight into here for now. It's found the library for us. Stream is missing. They did just a static stream there. lock that there for now. Device ID is missing, or device info. Doesn't know anything about ID, so straight away that doesn't actually work. Device info gets device info back, but then there is no ID on that info. There's name, driver, type as default, there's loopback, so there's no ID. Now I'm guessing the ID is going to be this that's passed in. Device, not really. So we can't get past that point straight away, which would then lead us down needing to Google for samples anyway, so let's just ignore that. So maybe this is a version specific thing. We have 3.1.1 here, so let's just jump back and let's say literally this doesn't work with version 3.1.1. Apologies for the confusion, you are correct. The previous code sample may not work with 3.1.1, so now it's updating the code to apparently work. The main difference is, so it even explains what's changed: record start call and the signature method. Well, that wasn't the issue we had, but let's go with that. Users find parameters passing the callback function. We're passing in .0 because we don't have a callback. Okay, so let's just try again anyway, see if this works. Paste it straight in. Should initialize. And exactly the same info. Recording it. So I'm going to try and get past this at least, because I'm sure that's just going to be like 0 or 1 or something. So let's just put 0 for now to get past at least that bug. Record set device doesn't work, and even though it says it's for 3.1.1, that doesn't work either. So we just type device. There's not anything like that either. So maybe this is, I don't know, maybe this managed library is filtering for platform, but again that just doesn't work. Let's just put this doesn't work for Mac. And now we have some weird base net registration. I keep calling it bass, not base. So this, no, it's using core audio, which is Mac specific. So it's getting device for that. Still got the wrong code there. So nothing's really different there. It calls core audio, which wasn't the problem. So none of those have really helped with the simple issue that this doesn't work. There is no record set device. So I don't know, let's just copy that and just tell it that that doesn't exist. And then it's now telling us that it looks like record set device was removed in version 1.0.7, but above we asked it to write us code for 3.1.1. So the problem with this is it comes across as very intelligent, and the way it writes the code and explains the code makes you think it knows what it's doing. But quite clearly from then telling it that that doesn't exist, it shows that it's incredibly stupid. It has no idea of what it's writing. It's managing to spit out code, but the code doesn't work. It's missing bits of info. And now it's adding registration info for no reason. So let's just ignore that bit, registration. Let's see if even this bit works. See if we can get anything useful out of this. Nope, so you still got the device ID, which also doesn't exist. And I guess if we put, let's kind of tell it that as well, why not? So, device info does not have an ID property. See what it has to say about that. So it seems if you tell it the problems, it will try and then tell you a solution, but you'd have to tell it every single problem in every single line, which then is on the verge of pointless, because why are you bothering to do that? You can just look at samples or use your brain. So let's try name, and it's recommending underscore name, which again doesn't exist. So this is expecting us to have a license for whatever reason. It's also still using name, which doesn't exist. So I'm just going to give up on this one for now. So that's ChatGPT. Bit useless in my eyes. That was at least a play. It seems like it knows what it's doing, but it clearly has no idea. So let's just take a look at the samples repository and see how long it'll take us to figure this out. So we have a sample for Mac, which is an audio player, which is no good. We want an audio recorder. We have just the managed bass, which I think is where we've just been. That's not the place then. Let's try WPF. Here we go, samples. 3D test, ported from bass, sample, 3D test. So it just tells us it's ported from other samples. So I guess we'd have to go to see those samples. So recording test sounds like what we want. So let's go to source, recording test, audio recorder maybe. So recording device. Don't see that anywhere. There, recording device. So let's just start with this class. And for now, because I'm just using, we're getting going and we're testing again, just going to break all the rules of clean code and dump everything in one class file. We can always come back and clean this up once we're satisfied things work. So we have an enumerate that simply looks into base.get device info, and it goes by an integer, which is coming from where exactly? It's just literally starting at 0, getting the info, and adding up. That's never going to stop then. That returns a boolean. So that will, once that fails, this loop will stop. So it's going to just keep attempting to get device info until it finds one. Then it's going to return a new instance of this class with an index and a name, which seems like possibly where that ChatGPT was pulling this info from, because this has an index and a name, but then again it was ID and name, but it's clearly pulled that from some random place. And then to dispose of it, which... Oh, it's disposable, yeah, cool. So recording device is disposable. It sets the base current recording device to the index of the device and calls record free. So that will be garbage collection. So that looks like an easy way to enumerate devices, I guess. So I wonder if it's just as simple as, let's just spin up a new instance of this in main view unloaded for now. Oh, sorry, main view of this rather. And just call capture default input. So lazy way to just spin it up. And in here, let's just use the console to try and, I guess, make use of recording device. Let's just jump back to the samples, because I'm sure they're probably going to do that as well. So back to audio recorder. So we have, when you initialize a recorder, which I guess we could do, which is when you initialize this audio capture here. So we could change ours to audio capture service. You can expect a recording device. I guess if that's how they want to work it. They've kept a device and a handle like so. So you have to pass in a device. Just going to rename that. Going to rename these. Can't quite not clean up something. And it just sets the device to an integer, so it's just literally an int. It calls recording nit, which we saw, I think, in the ChatGPT code. And in this case, it's initializing it with a device. Then it's calling record start. So it's less code than that ChatGPT spat out. This is much simpler code. And it keeps a handle on the return status, which is what we'll have to release, I presume. We set the frequency, the channels. Not sure what base flags are. Starts the recording paused. Use channel play to start it. Use 32-bit floating sample point data, WDM drivers. Loop the file. Okay, so this is a bunch of flags you can apply. So this is probably stuff we need to do when we come to process the data. But for now, it looks like all it needs at least is just something to tell it how to start, I guess. And now it's got a procedure, which I presume is the callback. So we will chuck that. I want to move that out of the way a minute. Don't want embedded classes. In fact, let's just at least make it semi-structured. I can't remember what I called the class. Let's just paste it in and then change it. Recording device. So I tried to start off messy, but I kind of can't. I need at least to organise this in some way. I really want to wrap regions and comments in it as well, but I'll refuse to do that for now. In case this doesn't work, then we're just wasting our time cleaning code up. Right, it says recording device in its own class, as it should be. And now back to what we were doing, which is chucking this procedure in. It's got a buffer array, so let's move that to the top where it should be. And I don't like these undefined values. Same here. Add missing namespaces. So this starts recording. This clearly looks like a callback, otherwise where's the data going to go? Use channel start and pause and stop. Recording can also be started in a pause state. The user-defined function to receive recorded sample data. Yeah, so that's what this is. It's got a handle, which again, don't like uppercase. So if buffer is null or the length is less than the length it's required, make a new buffer. Do a marshal copy of the data into the buffer. So now the buffer is going to effectively get the data, like our buffer with an underscore, which I also don't like. There we go. So our buffer data gets pulled from the buffer that gets sent in from an int pointer. So this is like a safe way of copying the unsafe data. And then it's adding what looks like a delegate or a callback. So it's just making a bog standard event you can hook into. And when we get the data, it sends that out. So that's a nice way of doing it anyway. Start just calls base.channelPlay with the handle. Stop calls channel stop with the handle. And dispose does what we saw, which is set the current device to the device and do record free. So to be honest, it's pretty much going to be a copy and paste of that example. That's, to me, perfectly fine. It looks easy, it's easy to understand. If it works, that is. And I always like to, I know you can just download the samples and run, but I always do like to type them in yourself so you get a feel for what you're doing and you know what you're making isn't something completely unknown. It forces you to actually, do something with it. Our class needs to be disposable as well, which is, for example, exactly what you might forget to do if you were just copying and pasting and not giving a thought to the fact that the class is disposable. So data available handler. There isn't one of that, so we need to find that. So let's just search in the repo for that. And there's the definition. I'll just chuck him up top for now up there. And again, lowercase buffer, lowercase length. So let's just wrap this, because I cannot resist. I need to at least clean up this a little bit for the sake of 2 seconds work. I won't comment it for now, I'll just at least put regions in there so we can see what we're doing. So how do we use this then? We need to spin up a new instance of this. We need to pass in a device, so it doesn't actually get the device, we'd have to pick one. And then we'd call, we'd hook into data available, and then we'd call start. So that would be the audio recorder. So they must use that somewhere else then. Main view model maybe. Yeah, so they're using that recording device class enumerate to add each one to a list somewhere, some UI list. And then I'm guessing they select it somewhere, and when they press play, it makes use of audio recorder. Yep, so... Oh, it also makes a WAV output. We're going to save this somewhere. So there's a WAV file writer. I wonder if that's... is that default? Go down a little rabbit hole. Oh, yeah, it already has a WAV file writer in Manage Base. So we might do that as well. That's cool. So again, I mean, we can pretty much take it on our own from here now. I'm fairly confident I know what we're going to do. It's going to literally start up an audio recorder from one of the devices from the list, and then hook into the event. But it looks like this is exactly what this is doing. It's also just making this WAV file writer, hooking into the data event like we said. That's passing it elsewhere, which we don't care about for now. On stop, it disposes both of them, and that's really all there is to it. So in our view model here, where we do a new one, let's just change this now. So let's just don't know, output. We'll just use command line for now. We will just output all devices, then select one. So for each var device in recording device dot enumerate, let's just do console.writeLine, and then we'll do device.id colon device.name. I wouldn't think that's possible to be null. Must be in some way, must be overlooking something there. So I guess we've got to do value in this case. Well, question mark dot index question mark dot name. Oh, we don't expose the name. Why not? That makes no sense. Let's change that. In fact, this could almost be... Oh no, it can't be. I was going to say it could be a record if it wasn't for that. But this will do for now. Just do that. Right, so let's just start with outputting the names to the command line. Let's see if this even works. Name doesn't exist. Name. Right, so that's running, and we can see in the command line here we do have default as 0, H&F, which is the USB mic. You've got the iMac's mic itself. So we do have, and I presume the default will be iMac microphone maybe. So reselect number 2. So just kill that. And we also, before we forget, where are we here? That's not disposable because we don't make something. Right, so now it was var, or using var audio device equals new audio capture service, and I think it expects a device. Yes, it does. We can just make one, which it was 2, and the name doesn't matter because we've made this up. Well, I presume it doesn't matter, and I think if we go in, it only uses the ID. So it sets the ID, and when we come to use it anywhere, yeah, it's just storing an ID, just an integer. So it's not really relevant in any way, and to be honest, it's kind of why bother passing that in, because it forces you to need that. We might as well change that to device ID. There's absolutely no reason to pass superfluous info into a function. So that will do. Nothing lost there. Change that to now just number 2, because we've just visually seen what we want. We've done the disposing because we've used the using statement, which will handle disposing for us when it goes out of use. And then there was audio device dot, is it data available? Yeah, plus equals. We'll just do an inline delegate, and on here we'll just write to the command line, and as it's bytes we'll just do bit converter to string, and just pass in the buffer, and that'll just dump out the string the byte array as like a visual string in the command line. And then we need to actually capture it. So that was start. I think that's all there is to it. So let's spin this up and see if we get, I presume, something spitting out on the command line, a load of audio. And no, we don't. So we get no callback there. Well, let's just double check over that we're not missing anything. So we got the event, we call, I haven't got, didn't the, I don't know, the recording knit any knit is any different, but if you remember the other code, the first code, it had base.init. I'm wondering whether we just need to do init in general first as well. And I wonder then if the sample code also calls init somewhere else, like maybe in the higher level. Ah, yeah, there. So it's calling the init. I bet we're missing that. So I've chucked that in there for now, which I guess it wants to be. That's more of an application specific thing, but for now just leave it in there. But that was likely our issue, to be honest. And let's see if this now works. Still nothing. So maybe it is the lifespan of the object. At the moment we're just chucking it in here as a using statement, starting it, and then it's never used outside of here. So to be honest, if we were to let's ignore, again, because we don't really have a place for it yet. Or do we? Yeah, we can. Let's do an audio capture service, and we're just going to have to dispose of it properly when the time comes. Private members of the entire view. Let's make a private audio capture service capture device. So we need to dispose of this, obviously, when we handle it correctly, but that will keep it alive instead of it being probably just as soon as onload is done, it gets disposed of. We could then just add like a timer and dispose of it after, but when you kill the app, it's going to clean up for now. And then we'll just put a quick note to do needs disposing. And I think on stop, no, it doesn't. So we do explicitly need to call dispose when we're done with it. Which, to be honest, in my eyes, is kind of almost... Oh no, because you're initializing it with a device, yeah. So every time we change the device, every time we'd kind of select and capture. So this sort of wrap here, it'd be sort of start capturing on a new device, and when you stop, I'd wrap it all up so it calls stop and then disposes as a whole, and you can't just start stop, maybe. But for now, just chuck that note in, and let's see if this thing stays alive and presumably captures audio. There we go, finally. So now we have a buffer that's null. We make a new buffer, we copy the info in, and we have a whole bunch of bytes. Nice. We call our delegate, which, there you go, starts spitting it out on the command line. So this is presumably audio data, which obviously quite clearly is. And we have it all kind of nicely wrapped up. And then I guess for the sake of it, why don't we just, that's default device. And what was the, oh, it's going to be way up the top now. If that's not already gone, here it's gone. I think device 1 was the professional mic I'm using at the minute, so let's just capture that one. And why don't we implement, just for fun, it's also usable and useful, I guess, as well, but this wave audio capture. So at the same time here, system.io.path, and we will output to what they're using is just the documents folder, and then they're also creating the folder, so that we'll just do all that ourselves. We'll just do the normal, so var output path equals my documents and my base. That'll do for now. If in fact you don't even need to check it, you can just be lazy and just do create directory. If it already exists, it'll do nothing, just saves on a check. So that will make the folder. This will create the file path of effectively today's date and time and .wav, and then they just did a writer. Now this is where we will have to implement we don't bother about it crashing for now. We'll have to implement some kind of timer, so it just starts recording for so many seconds and stops, otherwise we'll just have a permanent non-disposable class. So I could be probably really hackish and lazy here, but again this is just testing that it works. Let's just do a task.run, pass async in, we can then go back to doing the using statement, so it does get disposed, and then get rid of that. We will do using var, so that's disposable. The writer is also disposable, I believe, so just do a using on that. You don't actually do anything, that looks like that just starts it at the second you do this, so that just starts recording. And now all we want to do is do thread dot do task.delay, I don't know, 3 seconds of recording, await that, so that should keep everything alive, and then just let it finish, so that will now dispose. So if that works in a bit of a hackish manner, that should kick in, start recording for 3 seconds, and then stop and dispose. So we should see the output in the command line now show the actual input devices, and then presuming it doesn't crash, this should now be recording what we're saying, and then we should see this command line stop, which it looks like it has. So now, do we have a recorded WAV file? So the path will be users Luke M by, yeah, so the path isn't right on the specials, so it will have likely wrote the file, but it's just in the main users Luke folder. There we go, my bass with a backspace and then a WAV, so let's have a listen. And that hasn't recorded anything because it's 46 bytes. Well, there's a write.write, so maybe you have to do more than that. I don't think you just I know why, it isn't that simple. We've just overlooked the sample code and one of these callbacks, if I remember. I'm sure I saw somewhere, it's actually, there we go, writer.write. So as part of this callback here, we'd want to do writer.write. And we pass in the buffer and the length. Yep, and we're fine with that because it will, in fact we should probably stop before disposing so this doesn't crash. Let's just kill that a second. We probably want to do task.delay and then capture device dot stop. So it stops and then just give it a tiny delay to let any previous buffers filter through, so this doesn't kind of try right when we're finished. And let's run that again. And this should pop up with, again, the audio devices, and as soon as we see data on the screen, like right now, so as soon as we press F5, this should now start recording what we're saying while this is all spitting out. And now it's finished, we presume it's done, and we'll hear what we just said. So, there you go, 500 kilobytes.
This should now start recording what we're saying.
Perfect. So we've got a few seconds of recording there, so just play that again.
This should now start recording what we're saying.
Nice. So, bar the path being wrong, which is minor. Again, this is just a quick example. It does documents and it puts a backslash on. We don't need that. And that is all in. We now have an audio recording device. So, not only are we saving to WAV, which is handy for pre-recording, we also have a callback where we can get the data. So obviously this is understanding the format just by writing to WAV. Like, you're not telling it anything, you're just saying new wave format. So I presume this data is pure wave data in, it must be able to understand it. So now we've got this sample code, the next thing to do is analyze the actual audio data into some useful information to show it visually in this graph. a graph over here and a bar here, and all these fields of information. And to do that, we're going to use something called N-Waves. So it looks like N-Waves does pretty much all the heavy lifting for us, converting this unknown buffer data into usable bits of information. So you can see here already, you can have, I don't know if this also does recording inside, but we've done that now. This sample lets you load audio from a WAV, and it says all record audio from selected device, but we've already done that bit, and compute its MFCC vectors, so you can get effectively the waveforms. It looks like effectively we've got everything we need in here, so we can look at N-Waves after this to finally just get and extract these audio levels to output on our audio here, and then do this nice fancy graph so that we start getting something that looks like this. The colouring will be interesting to do, and these bars and things, but this bar is effectively done. On this side, we need to bounce this up and down, which is different than the arrow, so I'm not sure what I think the average is like an average, just a slow average, and the bar is more instantaneous. And then all of these fields of information, short-term, integrated, loudness, should be doable by this N-Wave. I think it gets us all that information. But what we'll do is probably get this bar working first on the up and down, and then make this nice graph, because this is the most visual impacting that we want to see. So we're not far off now, seeing effectively a fully working loudness meter. We're now capturing the audio. We can then always bind it to all these options and make these actually work. But that's minor, that's just literally binding buttons to events. I think the key info now is to get this final grid up and running and showing. So that's it for this one, guys, and hopefully in the next one we will be doing some nice visual UI on real audio, and this starts to become a functional application. Any questions or feedback, jump on the Discord and we can chat there. The audio topic is a lot larger than just the video. There's a lot more involved than just the loudness, so if you're interested in the audio side of things, definitely jump on the Discord.